All right, here we are back at the second part of the Desmos art activity. I wanted to show you a couple of different art projects that are up on the web now. This one I thought is adorable. It's from Monsters Inc. And notice that this person actually made the little edges on the smile. So when you make your art project, I want you to make it much better than mine. I'm just trying to make it quick so you don't have to listen to a gigantic long video. But notice over here, this was done by a ninth grader. And look at the amount of work that he or she put into this. Even have a sine and cosine function here. And let's see, what does this do? I think that might have been, they were moving stuff around so that it's not an animation. But you've even got a sine and cosine function in here. Let's see where that is. Sometimes you can see by the clicking it on and off. So one thing I want you to notice is how much work that this took. On the other hand, it's a little bit hard to find stuff. So now I want to show you an unbelievable one. This one is a Paris street. And what's interesting about this one, besides the beauty of it, is the fact that you notice that the folders really help clean stuff up. So for example, if you want to know what happened to the Canal Plus sign, you can undo the folder and see there's all the math that was just done to do the canal folder picture. So folders are really handy for organizing things. Now, I wouldn't expect you to do anything this beautiful. I have a minimum list of requirements. And again, like I said in the intro, this course can sort of be like yoga. You could do the minimum if you wanted to, or you could try to push yourself. Like I said, this is kind of off the charts. I had a couple from last semester that were absolutely gorgeous, and we will share them with each other in the discussion board, so you will be able to show off. So I hope that you really will put some time into this assignment, because you want to think of yourself both as a teacher who's thinking about what functions are being used, as well as a student who's thinking, wow, I really want to have this, say for example, this arc here, what function best illustrates that arc? So the motivation suddenly comes from within, and students really get interested in doing this. So let's get back to my poor pathetic little happy face here. Obviously I can change the color of this if I want to make it, I don't know, let's see. Let's make it black, since, and then we're gonna add a color for the face. But the first thing we want to do is add some folders to get this cleaned up. So you'll notice the plus sign here. I'm going to add a folder, and I'm going to call let's call the folder eyes. Okay, you can see how the cursor turns into a little mover thing here. I'm going to just move the eyes up here. Then I know that this green thing is what part of the eyes. So if I move this up here, notice how the line comes within that. So now that means that's in the folder. Also, this P and Q is part of the eyes. And now I'm going to expand that folder. And then if I close it, you can see that, yes, I have everything in the eyes. Another thing that we can do is let's have another folder that has the face, right? So, or the head outline, I guess you could say, head outline. So that includes, we can even include the, well, let's not include that. So this is the head outline there, that's that circle. And then the other thing that we want to do is we want to shade that. So we'll do x squared plus y squared is equal to 5 squared, but we want to make it less than, strictly less than, and we'll make that, no, they don't really have a yellow, but we'll make it orange. Not the best, but it's okay, right? All right, so now we can hide that or show that. And we'll put that like that. Now you see it's a little bit cleaner. All right, so now, let's see, this P and Q, they also went with the eyes. So let's put that up there too. So you can see it's getting a lot cleaner. Does that include the C? Yeah, the eyes included the C too. So let's get that out of the way. All right, now the next thing we want to do is we want to add an animation, because Bowers is making us do that. So let's animate the actual smile so that he goes from smaller to bigger. So right now we have this function y equals. Suppose I said Let's make this, instead, let's make this function say, we want to constrain the domain, let's say, for x, right? So we want, if the domain for x is 0, it would be right here. But we want x to sort of go out evenly from negative something to something, right? So what we need is a slider, right? So we know that the biggest it gets to is 3.5. So let's say 3.5 let's see, if I do 3.5 minus h less than or equal to x less than or equal to h. Let's see. Now it's going to ask for a slider for h. And so let's see. Oh, how cute is that? It's not what we wanted, but it's so cool. All right, let's just do, how about if we just do from negative h to h? Is that going to work? There we go. That is it. There we go. Oh my gosh, that's just too cute. Except h, really, we would just want it to go from 0 to 3.5. Okay, so now we can animate it, and you can see he goes sad-faced, happy-faced. You can also change the order and the speed. So let's make him go a little bit faster, and let's make it only go, let's make him always just being happy. So now he's going happy, happy, happy. That's pretty cool. So now you have an animation. My minimum requirements are at least 2 different functions. So I have a circle function and I have this ellipse. Obviously this is, again, very much under what the 9th graders were doing or the 10th graders were doing. So I'm hoping this is just going to wet your whistle. Come up with any kind of a function that, a design that you want. One thing that I've seen a couple times done, which is a lot of fun, is to make things on water and make the water move. So also notice that you can sign in here. You want to just sign in, click on the login. I already logged in, and then you want to save this graph. So I just click on here. I'll call this happy face. All right, click on save, and then it saves it. And then here you can see what other ones that you've done. Now we can add a new blank graph here. It's important to save your work because when you hand it in, I want you to hand in a couple of folders in one, but we're not going to do that this time. We'll do that next week. So if you want to just think about what water might look like, suppose we have, let's say, y is less than sine x. You've got some water right there. We can make our water blue. And you can make, for example, sine of x minus h. Okay. Now, as you animate h, your water goes along, which is kind of cute. You can have more than one function. You can have a bunch of different sine waves. You can put a function on here. So let's say you want to put a point on there. So let's say a comma sine of x minus a. Well, let's see, the sine of a minus h. Okay, now as this goes, you can see, wow, the point is stuck on the water there. It'd be kind of cute to put like a boat on there and even make the boat move in. So to do that, we're going to import the boat function, or the boat picture. So I go here to image, and there's my little boat. Actually, it's a huge boat. All right, so right now the boat is stuck at 0, 0. You can see the center is at 0, 0. What we want the center to be at the point A. Actually, let's do this. We'll just leave that for a second. We need this to actually be a function, so we need the y minus to make it shaded, but we also want a function. Let's just call it b for boat. B of x is equal to the sine of x minus h. That just puts it right on top of it. So now remember the water's moving, but the boat isn't, right? See, the x coordinate for the boat is A, and right now A isn't moving. So, but that's good, right? So, so the function right now is B of sine of x minus h. So if we want to put the boat, we could put the boat at the point A comma B of A. Now the boat is too big. Let's make it smaller too. Okay, but we want the boat to be to have like the same slope, right, as the tangent line there. Well, what's the slope of the tangent of this function? We could just call it b prime of x. So all you need to do is to change this angle to say b prime at A, which is really funny, isn't it? That looks like that's the actual tangent, but it might be a little bit steep. Let's do minus, I don't know, 0.3. Oh, that looks pretty good. So now I'm actually going to hide this part here, and let's animate H and see what we get. So now your boat is, whoa, it's going crazy, but it's going. So that's just an example of how you can use some really interesting math, a little bit of calculus, to make some more fun animations.